Good morning to all of you. Welcome to this lecture. In today's online lecture, we will discuss about the unit number 6, that is system design. So in the system design, it is for the both hydraulics and pneumatics. So for the lecture 1, we will first we will see the introduction, then about the one simple problem on the hydraulic circuit design. So syllabus is that of this syllabus for this unit number 6 is, that is calculation of piston velocity, thrust under static and dynamic applications. Okay. Then design consideration for cylinders. So this part is for the cylinders, that is for the design of hydraulic cylinders. Okay. So we will be discussing this part, that is design of hydraulic pneumatic circuits for practical application, then selection of different components such as reservoir, control elements, actuators, accumulators, etc. So we can also use the software, that is software for system design. You can use Automation Studio, but it is the paid software. So freely available software is the Festo software. So using that Festo software also we can do the circuit design. So course outcome of this chapter is that to describe the design of hydraulic and pneumatic circuits using manufacturer's catalog and simulation using any suitable software. So mainly what we have to do, we have to design the hydraulic and pneumatic circuit by using the manufacturer's catalog. Then we can also do the simulation. So learning outcome is, so in today's PPT is, that is learning outcome is that we have to identify the graphical symbols. See, this identification of the graphical symbols or ISO symbol, that will be same as from that in the unit number 4, that is hydraulic circuits, and also in the system design. Then to describe the circuit used in the system, so whatever the circuit is used in the system, that we should be able to describe whether it is meter in circuit, meter out circuit. Okay. Then calculate the parameters of the fluid power. So we have to calculate the different parameters like discharge, velocity, power. Okay, all these are the parameters of fluid power. Then lastly, we have to select the component, selection of the components used in the circuit. Okay, so normally what is this system design? We know that there are many applications like pressing applications, riveting applications. Okay, and we have seen their circuit diagram also. So only what we have done there, we have discussed about the only working of that circuit, how that pressing is done and all. But design part means what? Here you have to study about that. What is the flow in that circuit? What is the discharge? What is the power? How much power we are required to for the pressing? Okay, then what is the highest pressure available in that circuit? Then what is the capacity of the pump? What will be the capacity of the direction controller? Then what will be the size of the actuator? So all this will come under the system design. So basically we have to consider certain design considerations. Okay, so here first one will be what are the system design. It should perform the desired function of the application. So whatever the application is there, so we have to design such kind of circuit so that it or the we have to so that the performance is done for that applications. Okay, then we have to achieve the expected efficiency of the performance. So whatever the efficiency is there, that we have to achieve. Then to provide the assured safety, so safety has to be assured and reliability of the operation. So the circuit we have to design in that way that the safety of the operation we have to consider, and also the reliability. So the operation should be very simple, it should not be much complex. Okay, then to provide the simplicity of maintenance, servicing and longer life. So while designing the circuit, we have to keep in mind that the circuit should be simple for maintenance. So maintenance should be easy. Then servicing has to be done, and due to which what happens, the longer life of the circuit has to be there. Then we have to provide the allowances for some overload. If any case, if in application, if overload is there, so that has to be certain allowances we have to provide, so that the overload can be withstand in our circuit. Then to meet the above requirement in cost effectiveness, so obviously the cost will come. So whatever the circuit we are designing, so its cost has to be effective, that is with less cost we have to design. Okay, so the designer, in addition to selection of the components, they assess the interaction and compatibility of various components to be connected in a circuits. Okay, so in addition to the selection of the component, we should interact and compatibility of the various components should be available in the circuit, so that whatever is there, if any component has to be added in the circuit, so that provision has to be provided in our circuit. So we should require certain information for the design. We should require certain information for the design. So for the better design, the designer should have detailed information about the exact function of the system. So it's a relationship with the other units or processes and energy demand variation in this circle. Okay, so the demand, according to the demand, we have to design our circuit. Okay, so in general, what we can say, that the designer must have sufficient information about the, that is the following, that is like operating pressure. Okay, if the maximum pressure in the system is to be restricted, or designer has a choice. So maximum operating pressure, it is the very important part in the hydraulic circuit design, because we can first consider the operating pressure. So like if I'm considering the application of the pressing application, and maximum operating pressure is 200 bar, so that the pressure is fixed, and that based on that pressure I can go on select the other components. Then actuators. Okay, so in actuator, again, which kind of actuator I want, that is a reciprocating or semi-rotary actuator or rotary actuator. So already this reciprocating, semi-rotary and rotary actuator we have discussed. So for reciprocating means what? There will be extension and retraction. That is the linear movement of that stroke will be there. Okay, then again in reciprocating, cushioning will come. Then semi-rotary actuator, what happens? That is the angle of rotation will come, speed, torque. So that what is the torque required and all we will consider for the semi-rotary. Then again same for the rotary, the speed will be available, then torque, acceleration, retardation, this will be there. Then third important point we will consider, that is the operating sequence. Okay, so how the operation of the circuit has to be done. So whether it should be based on the time, okay, that is or it should be based on the event based or time based. Okay, so that based on this we can have the operating sequence. Then type of control, that is manual, mechanical, hydraulic, electrical combinations are there. Then we will consider the operating conditions, that is what is the location, surrounding, that is ambient conditions also we will consider, dusty, then corrosive atmosphere, then fire prone, whether that location is up to the fire prone, then tolerable noise level, skills of operator. So all these operating conditions we have to consider while designing the circuit. Then some special requirements are there, that is whether the circuit, it has to be continuous or it should be in the intermittent operation. So based on that the selection of the components will be done. Then daily hours of operation, so whether the machine which the circuit will be preparing, whether it will be running for 8 hours, 10 hours or 12 hours. So based on the daily hours of operations also we can design. Then special requirements of the working fluid. So depending on the working fluid also we can design. Then before this is the catalog. Okay, this using this catalog only we have to design the circuit. So this catalog will be available in the university exam, SPP university exam. So it will be at the last page. So here the different components uh, specifications are given. Okay, like strainer, you can see here the strainer, then pressure gauge, vane pump, then pressure relief valve, flow control valve, check valve, sequence valve, direction control valve, then cylinder and oil reservoir. So all their specifications are there. So we have to select from here only. So what are the available data is there, that is catalog is there. So from there only we have to select. So how can we select this? That is, if I have to select the S2 model. So for the S2 model, flow capacity is 76 liter per minute. So this we can select only when we know the complete details about the circuit. Okay, so for this hydraulic circuit design, so we have to refer this catalog. Okay, so I will explain with one simple example, which usually is asked in the exam. Okay, so in this exam, in this example, we will discuss how to design this circuit. So first example is that is about a machine slide. In the question will be like that: a machine slide is moved by a cylinder. Okay, so machine slide is there, it is moved by a cylinder. Then the motion required is as follows. So initially the cylinder moves against a load of 2.5 kilonewton. Okay, the cylinder will be moving against a load of 2.5 kilometer till it reaches the workpiece at a speed of about 1.5 meter per minute. Okay, so what this is the force. Okay, then reaches the speed. So this is the first meter per minute. So this will be the velocity. See, then what they are saying, the speed drops to about 0.5 meter per minute. Okay, so this is in the this is in only one stroke. The speed drops down to about 0.5 meter per minute as soon as the load increases to 12.5 kilonewton. Okay, then what they are saying, so this is happening in the one stroke only, that is forward stroke. You can see that initially the load is 2.5 kilonewton. Okay, and then here the load is changing to 12.5 kilonewton. So what you can see that this circuit, by studying only we can say that this circuit is the traverse and feed circuit. So because in the traverse, what happened, traverse and feed circuit, initially the speed is fast. Okay, then that is the rapid approach. Okay, then second will be the slow approach. So slow approach we call it as the feed approach. Okay, then the return of the motion is against a load of 2.5 kilonewton. Okay, so this much is the given in the statement. And again extra they will say that a meter out circuit is used.